All right, so we're moving on to chapter 21. However, it's really a continuation of hypothesis testing and the things we were talking about in chapter 20. So I wanted to mention something about rejecting and failing to reject. Because you saw me do both. We reject when our p-value is small. We fail to reject when the p-value is large. So the question I always get from students is, okay, so what's small and what's large? So what we're going to do is we're going to compare our p-value to what's called an alpha level. And that's the computer's version of alpha. You'll see me draw it like that. It's the Greek letter alpha. The most common alpha is 0.05. That comes from Sir Ronald Fisher, if memory serves, one of the, quote, fathers of statistics. He decided that 5% was really reasonable. But there are other alpha levels. 0.1, 0.01 are often used. And if a problem doesn't give you an alpha level, you can choose one. Actually, I should not say can, I should say you should choose one. All hypothesis tests should have an alpha level starting now. So it gives you something to compare to. We'll come right back to this little poem. So let's say my p-value is 0.03, and I have an alpha level of 0.01. Well, then that gives me the comparison I need. If my p-value is bigger than my alpha, right, large, tells me to fail to reject. All right, let's say I had a p-value of 0.0002, and I have an alpha of 0.01. Well, in this case, my p-value is smaller than my alpha. Small means I reject. All right, so the alpha is giving us that comparison, kind of the line of where small versus large goes. All right, and then here's a little poem to help you remember that fact. If the p-value is low, reject HO. Get it? Like, reject the null, HO. All right, so just something to keep in mind as we keep working on hypothesis testing. The last thing I want to talk about with hypothesis testing is the concept of errors. Now, this time, when I say error, I mean mistake, okay? Like, this is bad, okay? But they happen. When we make a conclusion in hypothesis testing, it's possible that we're wrong. Even with a p-value of 0.0003, that means there's a 0.03% chance that we could have seen those results with the null hypothesis being true. That's really small, so I doubt it happened, but I mean, it says it's possible. Unlikely, but possible. So we could end up making the wrong conclusion. So there are two kinds of errors we can make. And we use Roman numerals when we discuss these errors. So the first is type 1, and this is a Roman numeral 1. And this happens when we reject the null hypothesis, but guess what? It was true. Okay, so it was true, but we rejected it. That's the wrong decision. That's why it's called an error. The second one is type 2, right? Those are Roman numeral 2s. The null hypothesis is false, but we fail to reject it. Okay? Fail to reject. Again, we've made the wrong decision. That's why I call it an error. Some of my students struggle to remember which one's type 1 and type 2. Very, very common. So a couple things. The null hypothesis is false, but we fail to reject. I have 2 letter F, type 2. That might help. Some students also like remembering we fail to reject in a type 2 error. That might help as well. All right, so let's take a look at some examples and see if we can comprehend these errors. So I'm going to take you back to some things we've already done. So quick reminder, I won't read the whole story problem. We've seen this before. This was the one with the smoke detectors. And we wrote these hypotheses. The null was that the proportion of homes with smoke detectors is still 90%. The alternative said the proportion of homes with smoke detectors has gone above 90%. And in this particular example, we ended up rejecting the null hypothesis. Okay? That's what happened. So just to refresh your memory. So my question is, what kind of error might we have made? Okay, I'm not even sure we've made an error, but if we did, which error did we make? Well, in this case, we rejected. So it has to be a type 1 error. That's when we reject the null, but in an error, it was true. So this would have been a type 1 error. If you reject, your chance is of making a type 1 error. All right, we've seen this one also. This was the orange M&M example, where we had our p equals 0.2 or p does not equal 0.2. And in this example, we ended by failing to reject the null hypothesis. Okay, remember, fail to reject means if we made an error, the error we made here was a type 2. All right, let's see something we've never seen before so we can really get down to what a type 1 and type 2 error might mean. All right, a company is sued for job discrimination. That really happens because only 19% of the newly hired candidates were minorities when 27% of all the applicants were minorities. Ooh, yikes. So big job interviews, 27% of all the people that turned in applications, 27% were minorities, but only 19% that got hired were minorities. That seems to be a discrepancy. So they might give us some data here. We might complete a hypothesis test, trying to see if the company is discriminating. You know, or maybe it was just chance. Maybe those people were more highly qualified than others. So when I try to figure out anything about errors, the first thing I do is I actually write down my hypotheses. It helps me kind of keep things straight in my brain. So null hypothesis, if there's nothing strange going on at this company, then the proportion of people they hired that were minorities should have been that 27%, right? The same as that applied. And if they were discriminating, then that proportion would be lower than 27%. I'm not doing a not equal to here because if the proportion was higher than 27%, nobody would be complaining. So this one, right, there's no discrimination if they're hiring exactly the same proportion. And if they're hiring less, then we do have some discrimination going on. Not cool, guys. So what would it mean if they'd made a type 1 error? Well, a type 1 error means we reject the null, but that would be a mistake we shouldn't have. But I've got to explain what it means in context, okay? So rejecting the null hypothesis would mean I went with this one. There was discrimination going on. I said there was discrimination. But the null was actually true. There was no discrimination happening. So what could that mean for the company? The company might face some really big fines. Maybe they'll lose their business license. Yikes. And they didn't deserve it. So if this goes to the court of law, and I show that there's evidence the company discriminated, but they really didn't, that's really unfair, right? That's an error. The company is going to be in big trouble, and they didn't deserve that. Error. Okay, let's do the same thing, but this time we're going to explore a type 2 error. So remember, the null and the alternative. All right, so a type 2 error would mean we fail to reject. Okay, so that means we're kind of saying this one. I'm not 100% certain, but it looks like there's no discrimination, or at least I can't prove the discrimination, but I should have rejected. shoulda rejected, right? The null was false. So in this case, I don't prove discrimination. But it was there. So consequence, what does that mean? The company gets away with it. That is not okay. That is not okay. That is an error, and this one has big consequences, right? I guess in some ways, both of these errors have big consequences. If we make a type 1 error, the company is being treated very unfairly. If we make a type 2 error, those applicants are being treated very unfairly, and they never get their justice. The company gets away with it. So we need to be aware. There's nothing we can do to stop making errors. The truth is, we don't even know if we've made an error. We just need to be aware that when we make a decision, it's possible that we've made an error, so we want to be aware of the consequences.